Hello! In this video, we will learn about query expansion. Query expansion is basically a process to enhance a user's original search query by adding synonyms or related terms. Google adds synonyms and related terms. Why does it add them? This makes the query more comprehensive so that the query can be further clarified and the search engine can display more relevant search results. Within the system, query expansion is closely related to statistical machine translation. It is driven by the context map, which stores the synonyms, their usage context, and their relevant score. Now here you can see its patent: receive a search query, expand receive search query, select a word and associated context from received query. Next is identifying potential synonyms from the context map based on the selected word. After that, select a synonym based on matching the word's associated context with the context associated with each potential synonym. Then expand the query using the selected synonym. Finally, use the expanded query for a search purpose. Now let's say the query is how to ship a box. This goes into the trained statistical machine translation model, and from there it becomes how to courier a box. The second process involves a comparison model. The query how to a box is connected to the courier context map and eventually becomes how to courier a box. This means that the word that was better than ship was courier because more relevant search results were appearing for it. Therefore, it used courier here. So what is the role of the context map and synonym scoring in this? The context map is basically a data structure that stores potential synonyms from past queries. It contains associated context information about the word, specifically the words to the left and right of the target word. Additionally, there is a score, a numerical value that represents the likelihood that the synonym is a good replacement. This score is then determined using the translation likelihood, which is produced by the machine translation model. Translation likelihood combines language probability and translation probability. Now, what is language probability? It is how natural the output is in the target language. The second is translation probability, which asks how likely the output text is to be a correct translation of the input text. For example, if the word is tie, the context map might list not and Winston. It will give not a high score because the context word how to tie a knot fits well. However, Winston is found in a different context, like tie a Winston knot, so its score will be lower. The second step is the query expansion process, which involves matching the context and selecting the best synonym. The context matching system compares the context words, the words to the left and right of the main word, with the context words stored in the context map. Let's look at an example of the left context. How to tie a bow. The left context is how to tie a. Now the right context is bow, which comes after tie. In the right context example, the right context is bow. For synonym selection, synonyms with the highest matching score will be selected. Not will be selected over Winston because its score is higher, given the context, how to tie a and a bow. In the next stage, the search engine expands the query using the derived synonym. It adds the synonym to the query on the back end. There are two expansion methods. One is appending, which simply adds the synonym. The second is reformulation, where the original word is combined with the synonym using a logical OR disjunction. The query how to tie a bow becomes how to tie OR not a bow. The result of this is that both sets of results are included. The final query, which now contains a synonym, is used to search the corpus, meaning all the articles stored by Google. The benefit of this is that by using the synonym, it can find more relevant search results. Online versus offline translation for query expansion. What is the process for online translation? The search query is translated on the fly. How it works? The machine translation model directly translates the query, and the system identifies synonyms by comparing the original and translated queries. For example, the query is how to become a mason. It translates to how to become a bricklayer. Mason and bricklayer are both terms for the same profession. They are synonyms, revealing that mason and bricklayer are synonyms. Next is offline translation. How does this process work? Many queries are taken, pre-computed, and then saved into a context map. How it works. Later, when a new query is received, the system uses the pre-existing translation and expands the queries. What is the benefit? It saves time and is efficient because some translations are resource intensive. Therefore, this performs the translation very quickly. A real-world example, let's say the query is how to tie a bow. The word selection for expansion system selects the word tie for expansion. The context map shows two potential synonyms for tie, not, and Winston. In the next step, context matching and synonym selection occur. The system selects not as the best synonym. Following this is query reformation. The query is expanded using an operator, tie or not. This means that articles containing tie or articles containing not should both be displayed. What happens in the search results? The query is expanded and relevant results appear. Results for both tie and not are mixed together to display relevant results.